Welcome to Learn with Amine. In this video, we will be going through one of the top 75 interview questions. So it is called as counting bits. In this problem statement, we are given an integer n. We are supposed to return an array that is called as answer, and it has n plus 1 elements, and each of the elements is basically the number from 0 to n, and the answer of I. Basically, the elements would contain the number of ones in the binary representation of I. So, for example, n equal to 2 is a value. Now, our resultant array will have 2 plus 1, that is basically 3 elements, and each of the element will contain the number of ones present in the binary representation of the numbers from 0 to 2. So that means if n equal to 2, we take the numbers 0, 1 and 2 up till 2, and then we perform the binary representation of them, which is 0, 1 and 1, 0, and we count the number of ones in each of these binary representation, which is 0, 1 and 1, and that is basically our output. The same goes with n equal to 5. We take the elements, natural numbers or whole numbers from 0 to 5, and then do the binary representation of them, and then calculate the number of ones in the binary representation, and we will be writing the output. So that is basically the answer and explanation. Now this problem we'll be doing in two methods. Okay, first method will be built on the method that I performed in the last video, and another one would be a more logical. Okay, so first method is, let us jump into the program right away. Let us define the class which is called as solution. Now in order to do two methods, I am going to define two user defined functions. So let us call first one it as count bits self comma n is the only argument, and in the same way we are going to define another user defined function for the second method, which is called as count bits of 2. So let's go one by one. In the first user defined function, as I said, I will be building upon the solution that I did in the last video. So let me just explain what I did in the last video. In the last video, what I did was I performed the right shift on a particular number in order to find out if the least significant bit is 1 or 0. So that is the same concept I will be using here. Now let us first define an array. Uh, Let us name it as result, and it should contain n plus 1 elements, and each of the elements should be initialized to 0. So this is what I am doing in terms of the initialization. Okay, so that means result of 0, a result of 0 would also be equal to 0. So that is the value, actual value. So I'm not going to touch that. In order to find out the result of 1 up till result of n, I am going to do an iteration for I in range of 1 to n plus 1. Okay, because result of 0 value is already set to 0, which is the correct value. Now here result of I. In order to find out the result of I am going to perform the right shift on the element I, and then perform the bitwise AND operator with 1 in order to find out if the least significant digit is 1 or 0. So if we do this performing, then it would count the number of ones that is present in the binary representation of the element, and after iteration over the n values, I'm going to return result. So this gives us our output. Now the more logical method, which is easier, if you don't remember this formula or this process, thought process, Then we are going to do another method, which is let us assume that result is an array with 0 and it contains elements up. How many elements? N plus 1 elements. Okay. Now we are going to check for border condition. Okay. The border condition is fn equal to 0. Then we are just going to return result and the loop breaks over there. Now assume that n is equal to or n is greater than or equal to 1. Okay. In that case, result of 1 would be equal to 1. So this is the value set for result of 1. Now we are going to perform for I in range of 2 to n plus 1. Once again, we are doing this iteration from 2 because we know the value of result of 1, which is equal to 1, and result of 0 is already assigned to 0. Okay. Now we are going to check if I is even or odd. Now, if I is even. How do we do that? If I percentile 2 is equal to 0, that means that it is an even number. In that case, result of I will be equal to result of I integer division of 2. So how is this possible? For example, you take an element 1. The binary representation of 1 is basically 1, and the number of ones in the number is 1. Now if you take 2, the binary representation is 1 0, and still the number of uh, one digit is 1. Now if you double the value, which is basically 4, then it would be 1 0 0. Okay, 1 0 0, and it would still be 1. Now assume that we are taking the element 3. Okay, binary representation 1 1, and the number of ones is 2. Now let us double this. So with doubling, it would become 6, and that would be 1 1 0, the binary representation, and still the number of ones would be 2. So that means a result of I is equal to result of I integer division of 2. In the same way, if it is an odd number, then result of I would be equal to result of I integer division plus 1. Okay, so this is how we do it. After the iteration up till the elements of n plus 1, we basically return result, and this finishes our program. Let us see how this is going to work. Use my object function. Solution is the name of the class. Then take n1 equal to 2, n2 equal to 5, and then perform a print. Use the object, access the user defined function, pass the argument. In the same way, I'm going to do using the second method, and then I'm going to do this on the second element. Now if we run this, we are going to get the correct answers. So these are the correct answers, and this finishes our program. If you like this video series, please like, share and comment, and if you need any help, you can connect with me on Instagram or YouTube. Thank you, take care, and bye bye.